So let's begin for making this translate transform and this scale transform, as we are drawing this graphics from left top corner. As a default starting point for this drawing is from left top corner, so we wanted to make from bottom and left corner, how we used to draw from on the paper. So considering this paper, we are going to apply this logic for the scaling and transformation for this panel. So now in this graphics, we call this from this event arguments, we are reading this object and assigning to this G. So before creating graphics, we'll be calling this method for translate transform. Here I will be passing my left bottom, let's just say starting from this first parameter 0, and how much is the height for excluding this padding and this border, top border and this bottom border. So that value I have to give. So here I'll be giving this panel drawing and this client size and the height. So I'll passing this height. And next one is for the scaling. Again, for the x and y coordinates, I'll be giving 1 and -1 for the scaling transformation. So g dot scale transform, we'll be passing here 1 comma -1. Now what this impacting on my graphics? So previously it was drawing from this left top corner. Now this coordinates whichever we're providing, it will be starting from the bottom size. Now I'm running, and now let's see how it impacts. So first of all, now put this for the line parameters. Let's say it is starting from 2, and y1 is also 2, and x2, let's say gives something 120, and for the y2 also make it 2. So from here this line should start and it should end around here. So I'm selecting this line graphics from the drop down. Look at this, so it's almost touching to this border. So let's make it this 5, and then this is something 200, and make this 5. So now if I'll be reselecting this line from this drop down, it should be upward little bit and towards the right little bit. So you can see, and this almost crossing this size of this graphics. So this is how it can, again, if I change this to the 100 and if I reselect, it should be reduced. If I make this something around 170, the impact should be accordingly be drawn here. Same for the circle. If I give this starting from this 10 and then this y also 10, and width and height 100. If I'm selecting the circle, the circle should get drawn from here. Check it. So all these values from this text boxes will get applied to the line, and the line will get drawn. Same for the circle. These values will get applied here and it will draw it here. The next control which we are going to use is a flow layout panel. So if you see, this is the simplest panel in which we have shown this multiple text boxes and the labels. Now for sometimes there will be a requirement kind of arranging the elements or the controls in horizontally with a specific format from left to right. So then we need to add a flow layout panel. So in the toolbox, so in the navigate to the down below and just check this one, what it handles, this flow layout panel. If you over the mouse, it will give the descriptive information of this control, handles the layout of its components and arrange them into the flow layout automatically. So what I'm doing, I'm just dragging and dropping it this control here. So this panel control here, and you can see initially it will look like a normal panel. If you change the properties, then if you change the properties and you drag more controls into it, then it will show accordingly. So what I'm going to do, I'm going to change the basic properties how we change for the other panels. So first of all, border, I'll make this fixed single, so it will be visible even runtime as well. And the next thing which we have here, the checkbox, which we have this values in the drop down as a line and circle. So those line and circle will be adding as a checkboxes into this panel. So now go again in the toolbox and just drag this checkbox here and drop it inside this one, and get it one more and put it here. If you see, it is similar to the like checklist box, but we want it to be in a horizontal format. So go again in the properties. So you can see the flow direction. And there is a property of wrap contents, so indicates whether contents are wrapped or clipped at the control boundary. So we wanted to make it false. So then you can see this is now aligned a horizontally instead of vertically. So you just increase the size of it and make it size according to your requirement. So now these two checkboxes we are going to use instead of this drop down. So change other properties, font related properties for this panel little bit. So change these properties basically is to make it uniform. For other parameters also, now this UI is getting increased day by day. So what we'll do, we'll just reduce this font size for this whole parameters. So get rid of this combo box. We are adding this checkboxes further. So I'm changing this checkboxes text and the name, object name as well. So chk. So this is going to be a chk line, and for this chk line, the text also will be a line. And for the second checkbox, this is going to be a circle, and this is going to be a chk circle. So if you see these two checkboxes, we arranged horizontally. And now by checking these checkboxes, we are going to draw a line or circle based on these parameters. Go to the checkbox again and create event check changed. So for the first checkbox, chk line check changed, event created. For the second checkbox as well, this checked changed event has been created. Now for this checkboxes, what we were doing on this selection change of a combo box, which we used previously, now we are replacing this combo box logic with this checkboxes. So this panel drawing dot invalidate, this method we are going to call when there is a check change for the line and when there is a check change for the circle as well. And then we can get rid of this combo box from here. I'm just removing this combo box, and this event also related to it. Here if the checkbox of line checked, then this logic we are going to use. If circle is checked, then this logic we are going to use. So for the time being, just comment this section so to avoid some errors. Now I am checking it here. If chk line dot checked, if chk line dot checked, then I am going to run the logic related to the line. If chk circle is checked, then I'm going to draw this ellipse line from here. So this logic no more required, so I'm going to just remove it from here. So now just run it. So initially if you see on this, nothing is there. Now I'm going to put some line parameters here. So just put 5, then 5, then 100, and then 5, and just check this line checkbox. You can see this line getting drawn. I'm changing this value to 100 and unchecking this line. In short, I'm refreshing this line, so it is getting drawn it here. If you want to lift this up the line again, if you wanted to make some changes here, you can change, and you can see this line got lifted towards up, and this points also accordingly. Same for the circle as well. Put the parameters for the circle, how we want to create the circle. So I'm starting this from 5, and this width I'm giving 100 and 100, and checking this circle. So you can see this circle is getting checked. At this moment, this line and circle is already checked. So that's why it is showing this line and circle. I'll just uncheck, so this line will go away. If I uncheck the circle will go away. Check it, so all these values from this text boxes will get applied to the line, and the line will get drawn. Same for the circle, these values will get applied here, and it will draw it here. Now I'll start giving these values. Let's say this is first parameter 10, then second parameter 10, then x2 and y2 also I'm giving this, just let's say 100 and 100. So this, I'm just refreshing the line. You can see this line. If I wanted to make this horizontal line, you can see this is flipped. I just given this 10 parameter. For circle as well, giving this 100, 100, 100 and 100. So it should be at around here. The circle should get drawn. Now let's begin for changing some of the UI components and improving this code. We're going to get rid of this direct value passing. We'll be just optimizing our code. Also, how to use a structure for this parameter values. So we'll be having two structure, one structure for this line parameters, one structure for the circle parameters. First of all, just modify the UI properties. So for this form properties, we'll just make it as a geometry app form one. So geometry app. We'll be keeping this little bit taken down here, and this heading as drawing. So for this one, let's say something geometry shape. So this is geometry shape, and this is going to be input parameters. So this input section will be provided to provide the inputs, and then based on this input section, geometry shape will be getting drawn. So now go to this code behind, and as I said, one structure will be created for this line parameters and the structure will be getting created for the circle parameters. So create two structure, one line and another is a circle. So in this solution explorer, you can create one folder, and there we'll be keeping all the structures. So create a folder, structures. So I'm saying here structures, and inside that one structure, first structure I am going to add, just add new item. So this structure template, we do not have the structure template, so directly we'll be adding as a class template, and we'll be renaming that as a circle and line. So this is a line class I am adding it, and we'll make it as a structure. And one more, add a circle structure, circle. So instead of class, just rename it to the struct. So for the line parameters, what are the things which we have to add? First of all, the parameters x1, first field which is going to be x1, and then y1 and y2, x2 and y2. So here I'm making this y1, this is x2, and this is a y2. See, these are the four fields which we required in the line structure. And second thing, in the circle we need x, y and height and width. Declare this variables for, or the create object, I'll say line, and this is what we can say the line, and for circle, so this is a circle structure and we are creating a circle structure variable. And now we can pass the values, we can initialize these line and circle with some values, and we have the values from this text boxes. And one more thing, this UI, we have given all these text boxes just to make sure the default, there should be some default value. So what we will do, we will just make this default value for all text boxes as a 0. So here I'm putting the 0. Then for all other text boxes also, this is going to be 0. So what I'll do, I'll select multiple text boxes, and this text property is common to all the text boxes. I'll put this 0. So everywhere it is 0. And when checkbox is getting changed, what are the things that we required? So those many things we can just take it from here. And here we will just read these values as, let's say, line.x1 equals to, so here this convert is by default we can use, but sometimes there is no value, or just to avoid the exception when it is thrown from the, if it is not text, but if someone is like just removing the text and putting some alphabets instead of numeric value, we are expecting numeric values to be assigned here, then there will be a problem for converting this the text value or some special characters entered by the user to this integer, then possibly it will throw an exception. So to avoid it, we can use int dot, we can use this int dot try parse, and here we can use txt score x1, and what we are going to out the result out line dot x1. So this way we can make it out. So this is the text. So instead of this one, this simply we can initialize, and for other all the other values we can make it like this only. So those values will be available. Same way we can do for circle parameters as well. Here line dot x1. So for the line parameters, we have just reading the line parameters, and here we are reading the circle parameters. Now run and check how it behaves at the practical scenario. Now by default, if I check both, then there are no values, so it will just, it's a 0 0, so it is showing empty. Now I'll start giving these values. Let's say this is first parameter 10, then second parameter 10, then x2 and y2 also I'm giving this, just let's say 100 and 100. So this, I'm just refreshing the line. You can see this line. If I wanted to make this horizontal line, you can see this is flipped. I just given this 10 parameter. For circle as well, giving this 100, 100, 100 and 100. So it should be at around here, the circle should get drawn. Solid principle, that is of the first part, it's SRP, single responsibility principle. If you see in this drawing demo class, we have everything related to this line, circle, and for drawing line, calling this function drawing ellipse, everything is in a single class. And this is the UI reading logic. We are going to have a line, and for it there are some parameters. So we created this structure. Now when we go for solid principle, first of all we have to create a class which should have a defined set of responsibilities. This class should have its own attributes, its own method to execute. So from this logic, to behave this line parameter, when we interact with this line functionality, all the functionality attributes should be in dedicated class. So add a new class called line drawer. So add a line class, and in future we may have this multiple classes. So create a folder here, a classes. So I'm adding even folder here called classes, and inside this classes folder I'm going to add a line drawer. So here add new class line drawer. So this is my class. So first thing which we require, all the attributes. So here we just added the field, and while adding these fields inside this line attribute, we'll be using a smart fields of with the get and set, getters and setters. So this get and set will be adding for each of the each of this attribute. So we have this line parameters or attributes for drawing a line x1, y1, x2, y2, and the method which what this line drawer is going to do, it's going to draw, it's going to draw something, right? So we'll be adding one method, public void draw. So for drawing line, what we need, at least a graphics object and the pane object, and all these attributes are available here. So we'll be taking this input from this drawing demo. Here in this OnPaint event, we have this graphics object available, and this is the pane object which we initialize at the constructor level. So we'll passing here when we're calling this. So while writing a method, while passing the arguments into this method, first one will be a graphics object. So this is a graphics object, and second one is a pane object. So this graphics G and pane object I have passed. And now from this graphics G dot draw line. So this is the drawing of line we are going to pass, and these four parameters, pane, x1, y1, x2, y2. So these are the values which we are going to set from the outside. From the UI, we have this text boxes to pass it, and then this method to draw a line. So now if you see this class, how beautifully we have designed. So whatever the related to the line, everything is inside this class line drawer, and these are the four parameters, and this is the method which is going to execute when we call this from the UI side. So this is line drawer. Now to work with this line drawer, go to this class of this code behind for this UI. Here, whenever we are going to check on this line checkbox, all the parameters for the line should be assigned with some value. And where are these values now? Where these values are inside a line drawer class. So first of all, fix these values when we check on this checkbox. So here is the we have the line checkbox, and previously we were assigning these values to this structure, and the values inside the structure we have four integers and we were passing it there. Now we'll be keeping these values here itself inside this checkbox. So while passing these values, we'll be using an inline declaration. Let's say int, I'll be saying it's x1. So the value which is there in the x1 text box, just pass to the x1. This is a small x1 variable which I had declared, is called inline declaration. Second one is int y1. Then third one is int x2, and fourth one is a int y2. So these are the four variables which are which are getting set from this UI, and we have assigned this using a int dot try pass, and whatever the text value which is there in the text format, we are converting into the integer. Now these four values are ready, and next thing which is required to initialize the object of this line drawer. So at the class level top side here, this line drawer class object we can create. This is a line drawer, I have just declared it here. And now whenever there is a checkbox is checked for this line, then only we will be initializing this one. If chk line dot checked, if it is checked, then this line drawer equals to new line drawer, and all these values x1 will be initialized with this small x1, y1 will be initialized with the small y1, x2 will be initialized with the small x2, and same for the y2 with the small y2. So these are these local values which we have assigned from this text box values we'll be passing to while creating this new line drawer object. And when this checkbox is not checked, there is another else condition we are adding it. If it is not checked, that simply line drawer will be assigned with the null value. So we don't need this object anymore because this checkbox is not checked. When these values are passed, now we have this value ready, then object of this line drawer is ready. Then directly go here in this panel drawing on paint event. Here what we're going to do, we'll just comment this section which is the older which we used. Now here, if line drawer object, this line drawer object not equals to null, it means checkbox is checked, and then we can call directly line drawer dot this draw method. And what are the arguments required? This graphics object which we have got it from here, and then next one is a pane object which we declared at the constructor level. This pane object is getting initialized here with the navy color and of a width of 2, so it means thickness of the pane while drawing. So these things will be here. So only and only when this line drawer is not equal to null, then only it will get strong. Now check this logic. What should happen in the sequence when we will be running it? First instance, when we're running, it will execute this logic, and then when we check the checkbox, all values will be getting assigned to these local variables. And if it is checked, means this new object will get created. And when this event gets triggered, it is going to be a true condition here, and then draw will this draw method will get executed, which is written inside this line drawer class. So just run and check. So assign some values to this x1. I am assigning 10, and then this y1 is 10, and 100 for x2 y2, and check this checkbox. So you can see this line getting drawn, and then all the logic for this draw method which we have moved to inside a line drawer. So this is a single responsibility class which we created for drawing a line, and this is how it is executing the logic. So in the last session, what we have done, we have this single class solid principle and the single responsive principle we applied for this line drawer. So same way, we have to make a provision for extensibility. So in short, what we are going to do, we are going to achieve the abstraction for this requirement. Our requirement is to have multiple drawers, line drawers, circle drawer, then square drawer, rectangle drawer, polygon. There are multiple geometrical shapes to be drawn on this panel. Now, first of all, now this is explicitly we have created this line drawer. There should be a one abstraction level, a shape drawer. So what I'm going to do, I'm going to add a class here as a shape drawer. Add a new class as a shape drawer. Now, if you wanted to achieve the abstraction, we have to create an abstract class. Either we can go for interface or a abstract class. So I'm choosing here a abstract class. So internal abstract, and this is a class and the shape drawer. So this abstract class, what we want to achieve, our goal is to draw a shape. So simple draw is our requirement. That feature, the functionality should be achieved from this abstraction. So what we do in abstract class, abstract class is our thought process. Abstract class is a half defined class. We have to identify the key aspects, attributes, and the functionality. So I am having the functionality of wide draw. And second thing we have to remember, we when we create a abstract method inside a abstract class, that should be a public and then abstract keyword. So abstract public, abstract wide, and for this abstract method there is a new implementation here, so I'm terminating this with the semicolon. And now for this draw method, two parameters arguments we required. Here we have passed this graphics and paint. So these two arguments which we are required here in this draw method. So I have copied these two arguments here, and this is going to be implemented into the derived classes. So in the we have just declared this as abstract method here, and now this abstract method I am going to inherit inside a derived class. So here is my line drawer. So here how to inherit this one, colon and the class name. Now it is giving me the error immediately, line drawer does not implement inherited abstract member of a shape drawer dot draw. So here the method which we marked as a abstract, that method we need to implement here as it is creating a as we are inheriting this shape drawer. So that method, abstract method, needs to be implemented with override keyword. So I have this previous one draw method, so I will be marking this abstract method here as a override. So this override keyword I'm adding it here, so this error has been gone. So now one more, we have the shape here in this UI as a circle. For that also we'll be creating one class called circle drawer. So add that class circle drawer. For this circle drawer, this we are going to do from the initial one. So previously in one of the session we have seen this, these are the four parameters required for the circle drawer: x, y, w, and h. So x, y coordinates and width and height. So those fields we are copying it here and marking as a smart field with the getters and setters. So for other fields as well, I am just making these two properties. And then after creating these properties, we have to inherit this shape drawer inside a circle drawer. So I'll inherit this shape drawer, and then the method which we marked here as abstract, so that needs to be implemented inside this circle drawer, and this abstract method which we implemented should be overwritten here. Now if you see, we have this here in this line drawer, what we made inside a line drawer as a draw line, and here what we're going to do, draw a circle. Again this g dot ellipse method we have to copy it here, and this pane object and xy coordinates along with the width and height. So this class we have ready. So now this is a shape drawer is abstraction, line drawer is our derived class, and another derived class is a circle drawer. If you want to implement similar to this line drawer, then there will be two conditions: if line drawer not equal to null, and then draw. So same way, if I create the circle drawer, then there will be no use of this shape drawer abstraction. So for that, to achieve this abstraction, what I'm going to do, this I'm making this list of shape drawer. So these are the shape drawers, and I am going to initialize this. Either I can initialize it here or I can initialize inside a constructor. So this shape drawer can be initialized here in the constructor. And then this shape drawer may contain a shaped line drawer or a circle drawer. So here we have written this null object for the line drawer because we initializing it here if it is checked, and if it is not checked then marking as a null. For the circle we don't have the logic, so we have to write the same logic how we have written it here. However, we have to make sure we are adding this new shape inside this list. So first of all we'll change this logic of this line drawer for adding inside a shape drawer. So this is a shape drawers, add a line drawer, or this initialization of new line drawer we can just copy it and we can paste it inside the line drawer. So this additional line of code we can take a read of. And the shape drawer, when it is not checked, all the objects from this shape drawer we have to remove it. So we're going to use this remove all. So remove all the elements that match the condition defined by the specified predicate. So this predicate logic, how we're going to write using a lambda expression. So for example, this is a line. Okay, so I'll just say l, and the matching condition l is a line drawer or a circle drawer. I'll say line drawer. It is because of it's a line drawer. So if it shape drawer contains L object which is of a type of line drawer, so that we are going to remove all kind of line drawers from this list. And for the circle also we'll be changing if chk circle dot checked. If it is checked then shape drawers dot add new circle drawer. And for circle drawer what we need, these are the xy coordinates and y, then this xy coordinates as well as width and height. However, the parameters how we changed here, out int x1 y1 x2 y2 for the line, same way we have to replace here as well, because this is the structure we created in the previous session that needs to be replaced with the inline declaration of int x, then inline declaration of int y, and width and height. So int w and int height. So here while assigning, so this x equals to x, then this y equals to y small y, then this w equals to small w, and then h equals to small h. So this is how we are going to initialize it. And if it is else, all the circle related parameters we are going to remove it from here. So this shape drawers dot remove all, and this is going to be a circle related. So I'm just using this C is a circle drawer. So this is how we are going to. When it is checked, this shape drawer will get initialized with the circle drawer. When it is line is checked, this line will be get initialized. And we have separate two classes, this line drawer and circle drawer. And here in the panel on paint event, so this on paint event should be updated now. So all these things are required for this translation transform logic scale transform. This is at the top level we required. However, this logic now will be implementing with the for each loop, as we have the list of shape drawers inside shape drawer inside in the shape drawers. So this drawer dot we have draw method, and simply we are going to pass this g object which we created here and initialized here, and g, and this pane object which is initialized at this constructor level. So and this older code for the structures of line and circle we can remove, as well as this unnecessary object creation and declaration we can remove it from here. Also these two structures which is older now, so this whole thing we can remove from the our code base. So the unnecessary namespace also I'm removing from here. So now our code is clean and ready. Now check and run how it behaves in this current scenario. So I'll be providing some parameters for this line, x and y coordinates 10 10 and x2 and y2 100 for demonstration, and just check the checkbox. I can see this line get drawn. For circle as well, putting some parameters here, or just put this x is 100 and y is 100, width and height is also 100, and click on this circle parameter. You can see this kind of shapes are getting generated here. How to draw this class designer diagram or UML diagram using a Visual Studio step by step. If you do not have a existing feature to add this class designer, how to install and how to modify a visual designer to make this available into the Visual Studio, step by step. Now let's begin for how to create a class diagram and kind of UML diagram you can see to know the relationship between multiple classes or abstraction, how we have achieved it. If you wanted to install this class designer into your system, so you have to go to Visual Studio installer. So wait for loading it. And now if you see, this is the Visual Studio which we have installed. Now click on this modify. So there are the multiple things which we have installed here. It can be shown into these workloads. If you wanted to install individual components, component specific features, then you have to click on this individual component. You can navigate directly to the class designer, or here you can just type it here, class designer. And this checkbox you have to check, and it will show how much space required for installation of this feature. And you can click on install while downloading. It will take some time for installation. Once this is installed, you can restart the Visual Studio. After restarting Visual Studio, you can open the same project which you are working and just right click on this, right click on our project and add new item. So here you can see the multiple items like adding of a class, interface, and so many things. And here down below, you can see the class diagram. From search diagram also, you can just search like a diagram. If you search diagram, there is only one component which matches this diagram, is called class diagram. And you can provide a name for here like shape drawer abstraction or this UML diagram. Simply we can say as a UML diagram. So I'm adding this UML diagram into my project, this extension of a CD class designer. So this, if it is closed, we can again can find into your solution. This looks like something the symbol of a class, and the classes which we have designed directly you can just drag and drop here. For example, this is the line drawer. I dragged it here. You can see this is a line drawer. I can see. So in a single kind of block diagram, you can see this my class name and these are the properties, and there is a one method called draw. If you double click on it, you can directly navigate to your method itself or the class itself. And now I mean again coming back here, from showing the association and the linking with the abstraction and the derived classes, there are the more properties available. If you right click on this, you can show base class. So this is the my abstract class as a base class. I can see it here. You can just expand this arrow menu here, and you can see this is how it is related to it. So this line drawer is inherited from this shape drawer. You can see this clearly from these pictures. And this shape drawer, if you drag this shape drawer before this line drawer, and if you wanted to see how many derived classes there, you can just click on this show derived classes. So there are the two derived classes which we have, circle drawer and the line drawer, and these are the properties and the methods inside this circle drawer and shape drawer, you can see. So this gives a clear picture for us to identify what exactly the relationship between these two classes, between this abstraction of a base class and a derived class easily. Now few of the things which we are going to modify here, for example, this is the panel we have. This is a white background. If we wanted to change this background as like default of Windows system background as a blue, you can change it this blue background. And we can change this some coloring of this code as well, and just view code, and here with so this is the navy color which we have. We can change to, let's say, white color. When we are running project, we know this is Windows operating system and we are running it. In future we have extensibility for running this product into a platform independent level, maybe a Mac OS, then Linux OS. So this product should run, let's say, this geometry shape we are running on the Windows system. We'll make this either for Windows system or the Mac OS. So I change this label to Win oblique Mac OS. When this is on the Windows system, we'll make this as a blue background, and when it is on Mac OS, we'll change it to the a black background, just for the identification and differentiation between these two systems are there. When this project runs, it will start from entry point of the application from this program class, and inside the program class, this application class is calling a run method, and we are passing this first form which is going to appear in front of the user. So let's consider, before appearing this form to the user in front of them to operate it, we should identify the platform. So here call a platform identification function. So let's say we'll say here we'll add one folder to create this factory design pattern. I'm adding a folder, let clear platform classes, and in this platform classes, here while creating this abstraction of the shape drawer, line drawer, circle drawer, we created same way abstraction. We have to achieve one abstract class for the platform handler. So this platform handler is a one class we have, and this class which we are going to make as a abstract class. So this platform handler is abstract class, and from this abstraction we are going to implement two things: win handler and Mac handler. So now this platform handler we are going to inherit inside this Windows handler. So the structure will get create a structure of a abstraction. Now this UML diagram it will get create for this platform handler. So this is platform handler abstract class which we have added, and from here there are the two derived classes is a Mac OS handler and Windows OS handler. However, which platform is running, that we have to identify from our class. As I mentioned here in this program class, before running this application or before showing this drawing demo form to the user, we have to create a we have to check which platform it is running. So now this is a static method. So one more static method we have to write it to get the platform. Static kind of return type for this platform is going to be a platform handler. So I'm going to initialize that class only which is of a platform type. So platform handler and get platform method which I have created, which is going to be return this platform handler. So static platform handler, and we can say simply handler. This platform handler is going to be written from this method. But how will identify from this platform handler which handler I have to return it? So for that we have this inbuilt a platform ID as a enums. So from this platform ID we are going to identify a platform using a environment class environment.os version.a platform. And if this platform is a Windows, then we'll return a Windows handler. If platform is a Mac OS, then we are going to return a Mac OS handler. So create a switch case to identify this platform, and it will, if I just press the down key, it will implement all the default cases based on this platform ID. If you see this platform ID, all enums are created there. This from older system Windows 32 S, Windows 32 Windows, and this is the latest one which is there for the Windows NT, this new technology. And for this Mac also, this is going to be a Mac OS X if it is a Mac operating system. That Mac operating system will use with respect to the simulation. So I'm just removing which cases which are not going to execute at all on this demonstration. So I'm just removing. I kept this Windows NT and this Mac OS X. So when this platform is returning a platform of Windows, so this handler equals to win handler, and if it is a Mac OS, then this is a Mac handler. So this method will be calling it here, and it will return this platform. We can directly pass this platform inside the drawing demo as well. As of now, just returning the platform ID. So if you see by running it, what kind of platform it is returning. As of now, this is a Windows system, so it should return a Windows Win32NT. See, now here I am getting this value of this Win32NT, and definitely it will go inside this Win32 and it will return this handler of initialized with the handler object. So this handler is containing a Windows handler. So this is a kind of platform we are returning. So which platform we want to run? So this is a factory we have created, or get platform factory also we can say. And now this platform, I have to tell this my drawing demo class with the injection of a constructor. So I'm telling it here a platform handler, and kind of a platform handler object I'm just creating it here. And for this object as well, so now this is giving me the error for inconsistent accessibility. So we have this is as an internal, I have to make it is public, create as a private object for this one to get assigned this injected value at this level with the underscore platform handler, and this is a platform handler. And from program we'll pass this method directly here, and I am deleting it here from this platform. So now this first part is ready for getting this platform factory and passing it to the construct injections of this drawing demo. Now for creating this line drawer, we have this draw method, and here this graphics and pen object we have passed. Now we have to do little modification for the shape drawer of a additional of a platform. Graphics, along with the graphics and pen, we need one more object of a platform to identify on which platform we have to draw this line. So for this shape drawer, we have to modify this one with the additional of a platform handler. So I am modifying this platform handler it here, shape drawer, and this abstraction should implement into the both classes. And this line drawer should be additional with the this platform handler as object. So in the line drawer, I have drawn this platform handler, and one more we have this circle drawer which we created here. Here also we need this platform handler because we updated this abstraction. So now this method which we have created here we are going to call this only the platform specific handler here. Now in this platform abstraction, so we need to identify the key aspects: public, abstract, white, draw line. And for this drawing a line, what are the things which we require? We need a graphics object, right? We need a graphics object, and we need a pen object here. At least these things which required. And now this abstract method need to be implemented into both classes of Windows handler as well as a macOS handler. So this window handler, I will be implementing this abstract class it here, and for the macOS also I'm going to implement it. Now in the Windows handler, for this graphics dot draw line, drawing a line, what are the things we required? We need to pass it from here. So for here we need a pen and the further points x1, x2, y2. So these are the points which we required here. If you see, either float or integer points which we required. So these are the things which we have written here. We need inside this Windows handler. So for this, additionally, we need a parameters. So before adding this logic into this draw line of Windows handler, we had to modify this drawing of a line. So this parameter we need to initialize from the outside when we are passing this parameter. As of now, this parameter we are initializing from this drawing demo, and here are we are getting the parameters. So same way for this line, these are the parameters which we required. So we can create additional class of a shape params. In the shape params, we can add all the parameters which we required for the drawing a shape. So here in this drawing classes, we'll add one more class called shape params. So this shape params, for the shape params, these are the shape parameters which we required. So I'll be cutting it from here, all these shape parameters, and putting into the shape params. So for these shape parameters, now this shape parameters will get initialized inside a line drawer. If you see, so here I'll create a constructor of a line drawer and inject a shape parameter, and this is the shape parameters. And to get injected shape parameters at this class level, we need a private variable of a shape parameters. So once these shape parameters are injected, so those shape parameters we have to assign for this local variable which we created at the class level. And now here, for the timing just commented, now all these shape parameters where we are initializing inside this drawing demo. So now this line drawer, we have additional a constructor of a shape parameter. So here just put it this inside a bracket and say new shape parameters. So automatically it will get covered with this additional parameters. So in the platform handler, what we have is graphics G and the pane. we'll be having the additional of a shape params, and the other shape parameters. What are the parameters which we are going to pass it from there? This shape parameters, we have to make this as a public classes. Windows handler, we have this shape parameters as additional. Now the same method which we need into the Mac OS as well. So we'll replace this method with this additional parameters. And now here we can simply call this graphics dot draw line and this pane object. These are the shape params which we have as x1, then shape params dot y1, and so on. So these are this parameters which are required. So finally the line will get drawn from here. Now this Windows handler, which is a abstract method of this platform handler, we can call directly, we can call inside a line drawer. So in a line drawer, call this platform handler dot draw line. And what are the things required for the drawing line is a graphics G and then pen, and we need a this shape params. These are the shape params we require. So these three things which required to be passed from here. So this way structure will get changed for specific to the line. And now for this drawing a line, simple draw function which we have here calling inside this for each loop. So this is asking additional as a platform handler, and already we created this platform handler at this top level. So we'll modify this platform handler. So all set for the line. Now if you see how this diagram got created now, we have this draw line method everywhere. So same way, the same method which we need to implement into the circle drawer as well. So I'll just copy the same function into the circle drawer. I'll paste it here. But we do not have the shape parameters. So the shape parameters needs to be cut it from here and need to be passed the shape parameters inside this shape parameter, actual shape parameter. And those shape parameters should be passed from the constructor, and we can create this shape params as an object here. And for this shape params, we'll be passing this shape params inside a constructor as well, and assigning this reference of a shape parameters from this injected shape params. It will be available. So we have done this same for the circle drawer as well. Now this functionality of circle drawer and line drawer is available, and this shape params, now we can see this functionality got implemented in this way. Now additional things which we have to do is, from this drawing demo, we have to do this new shape params as well for the circle. So here we are doing this for the circle as well. So when this shape is circle line is checked, it will add this shape drawers and it will continuously draw this method. So we can run now. Put the parameters and you can check this is getting drawn for this Windows handler. Now this copy this same to the Mac handler. When this is a Windows handler, we have this platform of Windows and it is written in the Windows handler. But when it is a Mac, we have to simulate it here for the simulation purpose. So this platform equal to platform id dot Mac OS